All right, so the last time we were talking about the setting sun, but by the way, this if this were turned around and we were looking towards the east, it would be the same thing, right? In on the the first day of summer, we could start there. I guess it's often, since this is the beginning of the calendar year or towards the beginning of the calendar year, sometimes people start with December 21st. Anyhow, if you're in the northern hemisphere, the sun is as far south. So if this was the rising sun, right? I know because this is the west. It's the setting sun. But if this was the rise, if you were looked to the east in the morning of December 21st, or remember that it's around December 21st. The sun would rise as far south of east as it's going to get. All right. Then see what happens is as the Earth, revolves around the sun. What happens is very gradually the sun will, so as time is going on, you're in January, in February, the sun is rising, not as far south, not as far. Not as far south. I was right. Not as far south as it was, on just December 21st, the first day of winter in the northern hemisphere. So it's going further and further and further towards the north. Compared to where it was, it's going towards the north, and then on the first day of spring, right? So March 21st or so, it rises exactly in the direction of east, if we were thinking about the rising sun, and then you just break it into thirds, right? A month later, it's right around here. A month later, it's right here, and then so March, this would be April, May, and then June 21st, it would rise as far north as it's going to get. And so what it does is what's happening is the sun is taking a higher and higher arc in the sky, right? And this would be the day that it's highest in the sky, that it crosses the highest arc in the sky. And so you have the most daytime, right? Not the 24-hour period, but the amount of time that the sun is in the sky, right? In fact, in December 21st, of course, you have the most time that the sun is not in the sky, or the most nighttime, and that varies, right, according to what your latitude is. All right, let's see. So this is the sun changing positions, which we just mentioned about. You can using a finger as a measurement is not the best. Not the best way to do it, but I mean it's a good, like, kind of a rule of thumb, if you will. In astronomy, we usually talk about what are called arc seconds and arc minutes and degrees, right? So I'll do that. I'll do some examples with that stuff a little bit, towards the end of this chapter. All right. So the path, So this is the thing I was talking about with different latitudes. You're going to have this different. Let's say that this is your latitude is 23.5 degrees. You're going to see the sun at these different locations, throughout the year. You could follow the sun, and by the way, it swings between between the equinoxes, right? So the equinoxes, it would be kind of in the middle, and so it's 23.5 degrees either below the equinox or 23.5 degrees above the equinox. All right. So it's always that difference. Okay. That's the overall swing in the sun's position. Right. And of course that's why there are stark differences between winter and summer. Right. And by the way, the closer you are to the Earth's equator, the less of a swing. Right. I mean, it's still. I'm sorry. It's the same amount of swing, but the angle is not that much different between summertime and wintertime. Right. It doesn't make that much difference if you're towards the equator. When you're towards the poles, it makes a huge difference between whether the sun is in summertime or in wintertime. The closer you are to the North Pole, so the summertime, of course, the sun's going to rise as far above the horizon as it's going to get. But then, as you get towards the North Pole, there's this region on the Earth's surface called the Arctic Circle, and during winter time, the sun doesn't even rise above. If your latitude is above the Arctic Circle, which is within 23.5 degrees of the North Pole, the sun doesn't even rise, right? For several months, it just doesn't. But there's very few humans that live that far north. That's a really difficult place to live. And of course, in the South Pole, it's the same situation. But you got to shift the date by 6 months. All right, so let's. This is different civilizations around the world. So this is Mayans and Mayan civilizations, and these different pyramids. Pyramids being both the ones in Egypt, of course, and then the ones in the Americas. They are actually built, or were built, I should say, with the different positions of the sun in mind in different times of the year, right? These cardinal directions of north, south, east, and west, and you take Stonehenge, for example. The sunlight goes through this line on the first day of the summer solstice. All right. So and all of this, by the way, begins roughly 10,000 years ago. So 10,000 years ago, the human race becomes an agricultural race, right? So before that, we were primarily hunters and gatherers. When we start to plant and harvest crops, the knowledge of when to sow the seeds, when to harvest the seeds, and stuff like that. I mean, you didn't have this calendar. You had to pay attention to the sky. What was going on in the sky to be able to tell what time of year it was. The better the humans were able to do that, the better their civilization did, right? So you could grow crops, obviously mostly in the summer, in the spring and in the summertime, harvest in the fall, and then store the grain like that. That was a big deal too, storing grain in the winter time so that humans could continue to survive. All right. Now we're going to change to the moon here. The moon, rises in the east and it sets in the west. Just like the planets and the sun, the moon moves from west to east relative to the stars. Now remember, we talked about how the stars change position night to, just over the course of a few hours, but that's really the rotating Earth. What we're talking about is these fixed patterns of the stars in the sky. The moon is moving with respect to them, and it's moving from the west towards the east, because that's the direction that that the moon is moon is rotating around the Earth. It's actually, it turns out, it's in a counterclockwise way. The Earth is moving around the sun in a counterclockwise way. That's why it's all from west to east. The sun appears to rise in the east, but that's only because we're rotating from west towards east, and so is the moon. The phases of the moon. Let me go through the phase. It actually takes about 29 and a half days. I don't know why this says 30 days. 30. Oh, it says about 30 days. So it's actually about 29 and a half days, more precisely, for the moon to go through all its phases. You start with what's called a new moon, and then you get a crescent moon. And we add on to that a waxing crescent. So a waxing just means the crescent is increasing night after night after night. All right. So with a new, and we'll see this in just a second. There's a better picture of this right here, and I'll go through this again. So a new moon is when the Earth, when it's really the phases of the moon. Let me back up just a little bit. The phases of the moon are the changing angle, the cause anyhow, is the changing angle between the Earth, the moon, and the sun. When the moon and the sun are in the same location in the sky, they don't have to be right on top of each other. In fact, if they are, that's an eclipse. But they are in the same location in the sky, like in the same constellation, for example. That's the day that on that day, that's what's called a new moon. It only lasts for about a day. And then comes the crescent moon. And notice with the waxing crescent moon, the western side of the moon is illuminated. If this was the eastern side of the moon, the western side of the moon is illuminated, because if you think about it, the sun is just dipped below the western horizon, and if the moon is in this not exactly the same portion of the sky, but just a little bit to the left of it, then the western side of the moon will be illuminated. And then the next day, it's a little bit more. That's the waxing part, the waxing crescent. Waxing just means it's increasing, and then a little bit more. And then there comes a day, about a week or so, roughly a week after the new moon, and then exactly half the moon is illuminated. That only happens on one day, and that's called a first quarter moon. After the first quarter, more than half of the moon is illuminated. And anytime that happens, anytime that more than half the moon is illuminated, that's called a waxing. I'm sorry. That's called a gibbous. If that little more than half of the moon is illuminated, if there's going to be more of that the next night, that's called a waxing. Well, remember, waxing is increasing. All right, and then it increases. And by the way, it's on a given night, if you look at the moon, at 9 o'clock, go out the next night, the moon will be in the same location at 10 o'clock, or it'll be later, because the moon is moving around the Earth. All right, so about a week, I'm going to have to finish this probably in the next video, but after a week or so of the since the first quarter moon, you go through the waxing gibbous, and there comes a day when the moon rises and the sun just sets, and if you think about it, they're at 180 degrees apart. And if they're 180 degrees apart, the moon is fully illuminated. That's, of course, a full moon. By the way, with this one right here, for the first quarter, the sun sets and the moon is halfway in the sky. It's halfway between east and west. All right, so that's how you get the first quarter. All right, so all right, let me stop here.